Hi, Carly. Thanks for sending the notes from seminar. That was really, really helpful. I've got everything for this assignment figured out, so hopefully it won't be too bad of a one for you to get put together. So I thought I'd send you this so that you can get started on it a little earlier than tomorrow night. Um, I think what he's getting at for question one is the way I would look at it, anyway, would be I would kind of look at it as 1 plus 1/4, sorry, that should be a plus, and then the next one, because I'm going every, like the first one, and then count 2, 3, and then the next one, and then count 2, 3, and then the next one would be 1/7, and so on. And so I'm just taking every third one out of there. If I do that as well with starting with the second term, like 1/2 plus 1/4, plus 1/5 plus, what would the next one be? 1/8, I think, and so on. And then the third series would be negative 1/3 minus 1/6 minus 1/9, etc. So that's where he's getting the sums from that he gives you in the seminar. He's saying that if you add up all of the first terms, that 1/3n plus 1 would be the formula for each of those. So you can try it. If n was 0, then we would have 1/1 is 1. If n was 1, we would have 1/3 plus 1, or 1/4. If n was 2, we would have 1/6 plus 1 is 7, and so on. So that formula here represents the terms in the series to the left here. Now the next one is similar, but it's 1/3n plus 2 for every term that follows that pattern. And then the next one is negative 1/3n plus 3. And that takes care of all the different types of terms that are in this series. And that would continue on to infinity for all of these. If you keep putting in higher and higher n values, you would eventually get all the terms in this series, right? And so that's why he's saying that it's equal to the sum of n equals 0 to infinity of these three things added together, because that's exactly what it is. And so this represents the sum of all the terms from 0 to infinity for that entire series. So the only thing that you're going to have to do now to show whether it's convergent or divergent is to find a common denominator. And so our common denominator for these guys would be these three terms multiplied together, which is going to give us a cubic on the bottom. If we multiply 3n by 3n by 3n, we'll end up with 27n cubed in the denominator. So the highest exponent in the denominator will be that. Now in the top, we're going to have to find a common denominator. So for this one, we would have to multiply this and this to make that part of the common denominator. So we would have 3n plus 2 times 3n plus 3. For the next one, it would be this one and this one. So we would have 3n plus 1 times 3n plus 3. And then for the last one, you've got a minus in front, and you're going to do this one and this one. So you're going to have 3n plus 1 times 3n plus 2. Sorry, squeezing that in there. Okay, I'll put a little square bracket around that. What's going to happen now is in the numerator, the highest exponent is going to be an n squared for all of those terms. And you can multiply them out and simplify it to show that. But in the denominator, you're going to have a degree of 3 because of your 3n times 3n times 3n is going to give you 27n cubed. So for the p test, we have the degree of the denominator is 3, the degree of the numerator is 2, and so p is going to have to equal 1 here. And so if p equals 1 exactly, then we know that this series has to diverge, because for all p less than or equal to 1, the series diverges. So that's number 1. Number 2 is exactly the same thing, only he's already set you up with the formulas for all of the terms there. It's just that you've got the 2 minuses, but again, you're going to get the n squared in the numerator and n cubed in the denominator, so p will be 1, and that series will also diverge. I'm going to make you a separate video to explain question 3, and question 3 is not bad either. And then at least you've got all of that, and maybe we can work on that a little bit tomorrow night and talk about the quiz. So thanks for sending that to me. That was a big help.